every parabola has a focus and a directrix associated with it, and it's also true that every focus and directrix has a parabola associated with it. And in this lesson I want to show you how, if you have a focus and a directrix, how you could find the equation of the one and only parabola that has that directrix and that focus. I'll start with one where the directrix is a horizontal line and the focus is a point on the y-axis. And the easiest examples are actually ones where the focus is the focus and directrix are the same distance from the origin, in this case 1 unit. But one point that's definitely equidistant from the focus and directrix would be this point right in the middle, which would be 0, 0. And that's actually going to end up being the vertex of the parabola. So first thing to do, or first thing you can do, is get the vertex of the parabola. But now we don't know how wide to make this parabola. The way we find the equation of this parabola, I'm just going to draw a just generic thing here. This may not be to scale, it may be much wider than this or narrower than this, but this helps us find the equation. You pick a random point on this parabola, you just call it xy. Then you say, well, if this really is on the parabola, defined by this focus and directrix, then this distance would have to equal this distance. And that becomes an equation, because if this point here is 0, 1, then the distance, using the distance formula, would be the square root of x2 minus x1, that's x minus 0 squared, plus y2 minus y1, which is y minus 1 squared. On the other hand, this vertical line, think about this vertical line, this point here would be x comma 0. Sorry, x comma negative 1, I mean. So the length of this line segment here, see, from here to here is y, and from here to here is 1. So combined, the length is going to be y minus minus 1, otherwise known as y plus 1. And in general, it's going to become y minus whatever the y coordinate of all the points on this line is. Now, if those two things are actually equal, we get an equation, which would say distance from the point xy to the focus would be y minus 1 squared. That would have to equal the distance from the point to the directrix. Now I'm going to put an absolute value around here because there's a chance that it's upside down parabola, and then we don't want that distance to become negative. Anyway, in one sense we're done. This thing is an equation of the parabola, but in another sense it doesn't really look like we're used to ax squared plus bx plus c equals 0. So all you do is you square both sides, and you get x squared plus y minus 1 squared equals y plus 1 squared. You don't need the absolute value anymore, because when you square it, it turns positive. Then we expand. Plus y squared minus 2y plus 1 equals y squared plus 2y plus 1. These y squares actually cancel out, and the 1's cancel out. But the 2 y's do not cancel out, because one's positive and one's negative, and we get x squared equals 4y, which leads us to y equals 1/4 x squared, which is the answer. So this parabola is actually a lot wider than I made it, but that's the idea. Here's one where the focus is 5, 4, and the directrix is y equals 2. And you don't really need to know, even though the vertex is over here at 5, 3, but let's say we don't even know that. You don't need it. We could just draw this kind of generic parabola, put a point anywhere on it, call it xy. This distance is the square root of x minus 5 squared plus y minus 4 squared. And this distance is y minus 2. It's always y minus whatever the y coordinate of all the points on that line is. If you really want to see, this would be y, and this piece from here to here would be 2, so what's left would be y minus 2. Put absolute values around it in case it's under the line. Square both sides. X minus 5 squared plus y minus 4 squared equals y minus 2 squared. Expand everything. X squared minus 10x plus 25 plus y squared minus 8y plus 16 equals y squared minus 4y plus 4. These y squares cancel out. And when you add 8y to both sides, this ends up becoming plus 4y. Then if you subtract 4 from both sides, this becomes 25, and 16 is 41, minus 4 is 37. So I'll put it up here. We get x squared minus 10x plus 37 equals 4y, or y equals 1/4 x squared minus 10 over 4x plus 37 over 4. Often you get kind of ugly answers. If the focus and directrix are nice, the equation becomes kind of ugly. There's a more general way to do this. If I make this point at y equals just generic, y equals negative p, and the focus at 0, p, and I do this process, this is y plus p, this is the square root of x squared plus y minus p squared, and we get the equation square root of x squared plus y minus p squared equals y plus p. Square both sides, get x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. The p squares cancel out, the y squares cancel out. Get x squared equals 4py, or y equals 1 over 4p times x squared. Now, this value p, which is actually, you could think of it as half the distance between the focus and the directrix, or you could think of it as the distance from the focus to the vertex. We'll call that as p and p. There's going to be a relationship between that distance and between the coefficient, and the relationship is the a value, which is what goes in front of the x squared, is always 1 over 4p. Not 1/4 p, but 1 over 4 times p. The 4 times p happens first. The vertex form of a parabola is when the equation is like this: a equals x minus h squared plus k. That's compared to the other form, which is ax squared plus bx plus c. So the way, when it's in vertex form, the vertex is h comma k, which in this case is 3 comma negative 4. So that's the vertex down here. And the only other thing, I mean, you could get more accurate pictures, but this number out here tells us if it's negative, it's like a frowning parabola. If it's positive, it's like a smiling one. And the 2 means it's kind of steep. So I'll just make it kind of steep like that. Now remember before we had this question? Well, now we can do this kind of a bit of a shortcut way. Since we know the focus is 5, 4, and the directrix is y equals 2, halfway between those is 5, 3, and that's going to be the vertex. So our equation is going to be y equals a times x minus 5 squared plus 3. So the only question is a. Well, remember before, a is equal to 1 over 4p. And p is this distance, which in this case is 1. So this equation is y equals 1/4 times x minus 5 squared plus 3. So doing finding the equation in vertex form using this little trick here is really fast.